but not as my primary. I'd kill myself.
Well, I haven't ever known that.
The thing is, running Windows, Linux doesn't make a difference. And if you use it depending on the IDE, you know, I run the same IDE between Windows and Linux.
Yeah. The same environment, basically.
It's identical in every way. It looks identical. It feels identical. The only difference is that Windows won't actually compile half the code that I'm using. You have another cable.
We should probably test with your laptop.
Yeah, it's just gone grab my laptop there.
Oh, you can try this as hapa ama ni import inaingia tu virahisi sana.
Hajafika.
And then we realize
How many are you? I'm not sure how many people are coming.
It would be more than 30 or 40.
you have on the RSVP or for 130 something. No, but not everyone shows
Cable
up.
straight into the projector.
Yes, it's fair.
Yeah, just take this straight into the back. Oh, that's why it wasn't coming. Yeah, just plug that straight into the projector.
See,
Oh yeah, and see if it works. Yeah.
See, okay, now let's let us see whether can work. Let's go to that. It's okay. Doing something. Yeah. It's okay. So it's so no problem.
3 seconds.
Network. So that works.
So
Yeah, that
make it
works.
clear. Make it clear.
This one is.
Wow. So I think that's you. Now you're sorted out.
Yeah.
But the other one, just put it aside.
So
So I've understood that the cable is not working.
so
Also turn down the refresh rate on the laptop because I think
Make lights are leaving. Right. Yes, so it's coming up.
Didn't even notice you got one, really?
no, that's readable.
Don't worry, we tried to fix it. There's technical problems.
That's much better.
Thank you, my friend. Yeah.
I thought there was a
I
cable.
like you.
What do you
No,
think, dude?
nobody is perfect, my friend. Okay?
No, I like you. I think the
Okay, dude.
So guys, sorry for inconveniences. We are together. Welcome. Thank you so much. Right.
I'm gonna play Vitality. I have everything to do. I honestly don't know how long I'm gonna be playing.
I'm happy to start from you guys. I'll keep you guys.
I want to play Vitality.
so we're waiting for people to come, but I need to start. So my name is Juma. I'm the member for this Gophers group. So today we are playing first because we're going to cover it.
I really don't play hardcore much. I already thought about playing hardcore, but I decided that I would play hardcore instead.
Also,
But honestly, you bring up a
I think
good
the
point.
person was
Maybe
supposed to
just switch
start
from
with
hardcore to hardcore.
so you can do
Hardcore is a lot more
missions,
exciting than
you do like
hardcore.
a
I see what you say.
So that is
Ideally.
Thank you. So, firstly, let me tell you a little bit about who I am because my background influences some of what I'm going to show you. Firstly, I will start off by saying, and this is kind of bizarre to say, that programming Meetup, I am not a programmer. I specialize in low-level network research and development. And I've been behind some of the protocols that you use every day on the internet. My name was on some of those drafts in IETF, the Internet Engineering Task Force, the Internet Research Standards Group, etc. And for my day job, I head up R&D for the telecommunications group worldwide. And I am not formally trained to code either. My background, when I was 12 years old, I was kind of bored at school and I needed something to do, and the comp sci teacher was kind of irritating me, and so I decided I just learned to be better than her and irritate her right back, and she told me that our first project had to compile in a Pascal compiler, and that was all the instruction that she gave us, and that's a very stupid thing to say to someone like me, because I handed her something like a compile in Pascal compiler. It read begin, procedure X, assembler, semicolon, end. And she couldn't read a semicolon. And she was stupid enough to run that on the school server. And well, interesting things happened. All I'm going to say. And so I grew up teaching myself how to code primarily in assembler, Pascal, C. I abhor objects in their traditional form, because I believe that you can write the usable code without them just fine. And I focus on a very low level form of coding, because a lot of the work that we do is dealing with very big data, and it's dealing with binary data coming in and out of the network. That means that it's straight packets. Now, I did a lot of work in Python. Python doesn't scale. Python can't thread. The moment that you try and thread with Python you run into a problem of global locks. So if you take a server that's got 80 CPU cores and you fire up 500 threads on Golang, you'll notice you're never using more than 2 CPU cores because it's globally locking on your threads. That's a problem when you're dealing with big data. So then people say, well, we'll go multiprocessing. The problem is that the process communication is then based on pickle in Python, and that is slow as slow can be. So it just doesn't stay. So then you have a choice. You can go C, or you can go Golang. You can do it in C, but then you're a masochist because your memory management is a pain in the backside. And you're dealing with POSIX threads and POSIX mutex locks, and it just gets really, really complicated really fast. And effectively, Golang just gives you C with the ability to shoot yourself in the foot if you wish to do so, but you actually have to work for it. Right? So it is C without the pain. And there is kind of this myth that C is faster. That's because people don't know how to write Golang. So what I'm going to talk to you about today is 2 areas of Golang which are not particularly well covered, I find, and they're some of the more powerful aspects of the language. Number one is when we start talking about channels. Who here actually uses Golang channels in their code? Okay, so you all use Golang channels, and you all use Go routines. The problem with Go routines is if you fire 5,000 Go routines, try and keep track of them, what's running, what's not, and try and limit the number of Go routines. Not so easy. You have these things called wait groups. So I think you're going to need to kill the lights. Because then it's beautiful. Yeah, let's kill the lights there. So what I did at 4 o'clock this morning, I was originally going to present some stuff with PowerPoints, and then I realized that code doesn't fit well in a PowerPoint slide, so I just wrote some things that will work better for code here. So this is a typical little function that deals with Go routines, right? And effectively, all it does, get the start time so that you can then work out this is the start time of the routine. It creates a return channel so that the Go routine can return to the main function, because remember, Go routines don't have normal returns. And it goes ahead and it fires off a Go routine and it comes back sending the data back in. Really, really simple, typical Go routine code. And if I compile that, so I can see which one of these. One. And you can see, in fact, it's not even working. Yeah, it ended with a number, came back with a number after about 1.7 seconds, right? But now, if I want to take this and start firing a load of these things, right? So we'll now look at this routine. Let's go to stuff there. So over here, we're firing a whole bunch of Go routines, and this here will, it's actually, it says 25, it's 5, but it fires off the Go routines, it loops through getting the results. This is all fine, and it's going to come back with your results in whatever order the function finishes. No problem, your results probably aren't going to be ordered, but well, that doesn't matter. The problem is, if I tell that thing to give me 10,000 threads, it's going to go ahead and make 10,000 threads, and it's going to run that. But that could bring down my machine. So what happens when I want to take this a step further, and I want to say, hold on, I want 10,000 threads, but I only want 50 of them at a time. Now there are ways to do this in Golang in kind of traditional means. And if you look at this here, what this does is, there's a thing called a wait group, right? A wait group is part of your sync library. And you can, as you're firing your Go routines, you can add it to a wait group. 1, 1, 1, 1, 1. When you wanted to say, okay, I need that batch to finish, you call wait group done. And it halts any further processing until all of those Go routines come back to you. Nice in theory, right? But there's a problem with that approach. Because if, for example, I'm firing 250 Go routines, and I want to say there's only 50 running at a time, if they're all returning at different times because of whatever in the functions, if I have to wait in blocks of 50, I'm waiting for all 50 to finish before I start my next block. What I really want is a situation where I fire a Go routine or fire 50 Go routines, and as they finish, one after another, I want to start the next one. That makes sense to everybody? So, how would you guys go ahead and achieve that? Any ideas? Any ideas? You're close. You do use buffered channels, right? But possibly not in the way that a lot of people would expect. So, firstly, let me run this code, right, which is the wait group code. And you'll see, So you can see there, it's returning the weight groups one after another, right? No problems. But now, as I said, if you want to take this and you want to do this another way, you look at the function we're calling our go routine. I'm passing it two channels. One is called blocker and one is called release. The blocker is a buffered channel. That means that defines how many threads I can run. And the very first thing I do when I start that go function is I pass a value into that channel. As a result, if I fire 500 go routines, but there's only 50 in that channel, the moment there's 50 threads running, and if I pass another value in there, the thread blocks, it doesn't run. It sits there waiting until such time as there is space on the buffered channel. Then, at the end of the function, I send a value to another channel, which is a non-buffered channel, called release. And if I look at my main routine here, I go down here, we're not cycling through. So I fire all the threads at exactly the same time, but they're being blocked at the start of the thread. But in the routine, which now comes after I fired all of them in the loop, I read off the release channel, and the moment that I've got a release, I remove something off the block channel, which causes the next thread to start running. The net result of this is, as your threads are finishing, your other ones are starting automatically in the background. So you have a constant release, start, release, start, release, start. The net result of this is I can queue up 50,000 threads, tell it to run 500 at the same time, and not be waiting for a block of 500 to finish. It's one after another. It just starts there. That makes sense to everybody. Questions before I continue, because if I go much further than this and I'm losing you already, I'm going to really lose you. Questions? Come on, guys, this is interactive and I don't bite. And there's no such thing as a stupid question either, just stupid answers. I'm the monster. Go for it.
Are you able to modify it depending on the processes that you're running on? So if you have 16 cores, if you have 2 cores, you might want to use a thread someone, or the other.
There are system functions that will tell you those numbers of threads, and then you set your buffered channel size dependent on that. There are, various syscalls you can make to get CPU counts. I don't have any example code on me, but there is definitely stuff that you can do to read that information out of the operating system, and then based on that, set however many channels you want. In my case, I haven't really needed to do that because I typically know, the sizing of the hardware that I'm running on. I'm busy working on a big data analytics system at the moment, and I know that my servers have each got 200 and something CPUs in them, 255 cores. Thank you, AMD, for your epic CPUs. Rome epic CPUs, 64 core CPU with 128 threads on it. The most awesome thing, and you put 2 of them in a machine, and it still costs you less than 1 Intel CPU. But yeah, so this number over here, this 50 in the blockchain, you can set that whatever, and that's what limits how many Golang threads you run. So long as you can read that information as to how many CPUs, set it to whatever you want. Any other questions? So later on, and I don't really have example code for the actually I do, so I'll show you some other code where you can take this to extremes, because you can wrap all of your functions as function pointers into reflect routines, and then use this routine, this wrapper, to control all your threads for all of your functions, irrespective of the type of function. It gets very interesting when you start doing that though, because you start walking into the world of function pointers and everything else. This type of stuff though is, if you want to efficiently work with Golang, Golang's biggest advantage is its ability to multi-process and pass data between channels and functions and the rest of it. That's what it's built to do. And if you're not using your channels and you're not using your Go routines, then you may as well be coding in Python. Because this is the very essence of what Golang is about, those Go channels and the Go routines. And I'll show you a video. Then the Google team that created Golang did a video singing about how great Go was. And half the song is about, all my control routines are just passing around these channels. Because keep in mind, in a channel, you can pass anything over a channel. You can pass an interface over a channel, and an interface can contain anything. So effectively, you do realize that you can pass a function, actually a function pointer over a channel. So I can even tell a routine to execute a function it has no knowledge of by passing that into another function through a channel. We can get really, really interesting with this. So my advice to you is, if you're not using your channels properly, learn that. But this comes with caveats. And now we're going to get a little bit, this is the easy stuff. This is the easy stuff. How many of you have coded in C? Any C coders? Okay. So you know something about pointers, I hope, right? How many of you here know, what can you tell me about pointers? Who here works with pointers even in their Go code? Okay, so let me give you a lesson in coding in general, right? And this is my biggest problem with the kind of formal education system around coding. Here's a lesson for you about computers. Firstly, this concept of structured data that the industry loves to talk about, let me tell you something. Data is as structured as the structure you give it. The computer sees zeros and ones. It sees a bunch of stuff in memory that is zeros and ones. No structure to that. However, if you imagine that you've got a page with a bunch of letters all over it and it's virtually unreadable, you take a stencil that's got cutouts over it and you overlay it on there so that the pieces that you want are exposed. It becomes easy to read, right? All that pointers are allowing you to point to the different parts of the memory and manipulate them. And that means that you don't need to tell your compiler, go and fetch this and copy this and the rest. That's heavy on the CPU, and it's heavy on the machine. If you can manipulate the underlying memory, oh, the possibilities are endless. And I hope there are no university lecturers in here, because I'll tell you now, if you want to write optimized code, follow what I say. If you want to pass a programming course, forget everything I'm about to say. Here's the thing. Golang is a very typecasted language, as you probably well know. That saves you from a lot of yourself. However, there are many times where that typecasting can get in the way, and you can break out of it. And you can break out of it hard. So let's talk a little bit about pointers. And very basic pointers, okay? If I run that code, I'm not the C coder who will know the answer to this. What do you guys think is going to happen when I print over here? Yeah, I make it bigger. try 26. So if you look here, I'll tell you what I'm doing first. I have a variable, A, it's an integer, and I'm setting it to 50. Variable B is a pointer to A. So right now, if I print B as a dereference, which means print the underlying data, not the pointer. If I just put B there, I'm just going to get a memory address. It's going to print 50. But keep in mind, B does not have any data of its own, which is a pointer. When I change A over here, remember I have not touched B there. Watch what happens. You'll see B is suddenly 100 because I changed the underlying data, which is in A. B just points to A. Does that make sense to everybody? Okay, so that nice and simple, right? But now we take this to another example. So here I have two functions, one called no pointers and one called with pointers, right? No pointers, I'm taking in actual values, A and B, and then I'm resetting them in the function. Two, I'm taking in pointers and I'm resetting the reference of a pointer in the function. And if you look here, what happens here is, over here, I say no pointers A and B, so I'm setting them again over there. Over here, I'm passing in the references again. If I run this, and please note that that function at the top has no return value. I'm not returning anything from that function. You see, neither of them have got returns. You'll notice over here that the values outside the function have changed because I passed a reference, I changed it, and the scope no longer matters because I'm changing the underlying memory. So my function doesn't need a return because I've modified the pointer, which is outside of the function. That makes sense to everybody?
Yes.
Okay, now I'm going to get to why all of this matters in a minute. But first, let's take this a step further. So, in this particular case, I'm going to show you why pointers can also be a little dangerous, right? So if you consider this, I'm firing up a couple of Go routines, right? And that's non-pointers. And in that those Go routines, in the non-pointer version of it, I'm looping through and I'm doing A equals A plus B, right? And then I'm printing a result. Nice and simple. In the pointer version, I'm doing exactly the same thing, except I'm using dereference pointers, right? Star A equals star A plus star B. That's the references. Here's the thing. In the bottom version, the no pointer version, I'm going to get dead consistent data coming back because it's manipulating A and B as thread local. However, in the top version, I just created a race condition because effectively I've got now a bunch of Go routines that are modifying the same point in memory. Because star A points to a piece of memory, and if I point that into 4 different Go functions at the same time, and they all try and write it, They'll do so, but your results, and the net result of it is, if you have a look, when I run this, and the reason that I show you this is because when you're working with a lot of threads and a lot of control channels, a lot of your stuff is actually being passed by pointers. I'll talk about slices and interfaces in a bit. And you need to be aware of this, because you've got to be careful that you don't end up with a race condition. And if you look, this is the wrong, that's the wrong one. This is, so it's still up here, right? This is the first routine that I'm running. And the stuff might not be coming back in order, right? But you'll see I've got 20, 30, 40, 50, 60, 20, 30, 40, 50, 60 as the first return. It's working on local data. That is what you would expect. Look at the numbers of what happens in the pointer version. They're all over the place. Why? Because one thread is modifying the data that the other thread is now modifying. And has anybody ever used Golang's race detector? Does anyone even know that Golang has a race detector? Have you used it? Okay, so for those who haven't, if you do this and you build it with race detection on, and I run the same function again, you will see that Go is screaming at me because I am now modifying the same memory from different points at the same time. That is what a race is. But pointers themselves, people go, well, if pointers risk racing, etc., why would you use this stuff? Now I'm going to show you some, I'm going to get a little bit more fancy here. And has anyone heard of the Unsafe module? Anybody ever used the Unsafe module? Okay, so in C, you have straight access to your pointers. In Golang, you also have that, but you have to do it through a package they call Unsafe. Unsafe is not really unsafe. Unsafe is unsafe for people who don't know how to use it. Right? And I'll show you some other code later that shows you just how, I was talking to one of my colleagues and he said, when he started working for me a year ago, A, he wouldn't have known how to do what he does today, and B, he'd never heard of Unsafe, but now that he has, he couldn't live without it, because it is something that we use every day in our packet manipulations and in working with low-level binary data. Now, remember I said to you earlier that data is zeros and ones, it's byte arrays in memory, right? So let me give you an example. If I'm passing data across a network, it's a string of bytes, right? No structure, it's a string of bytes until I decode it. So how are you going to take normal data and get it into that byte array? Now, you can go and load things like encoding libraries and use put big endian this, blah, 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 long lines of code, ridiculous, etc., right? Or you can get a little bit fancy and a little bit more dangerous and live on the edge. Introducing the Unsafe module. What is actually going on in this code? Over here, I set a UN64 to 1, 2, 3, 4, 5, 6, 7, 8. Because remember, a UN64, 64 bits, that's 8 bytes, right? So I have this chunk of memory somewhere in my memory that's got 8 bytes. Now I'm going to turn it into a byte array. So I can call some other fancy function to go and get that and serialize it and the rest of it. Or I can take a pointer B. I can point it at A, at the start of A, tell it that it's a slice, and have B become a byte array that sits at A. And in one line, I now turn that into the underlying byte array for that UN64, and I will have an 8-byte slice of that. Now, obviously, the byte array for a UN64 will not look like 1, 2, 3, 4, 5, because that's not how numbers work. It's a binary 64 bits. But effectively, this byte array will be that. And to demonstrate that, ignore the bottom 2 lines, we'll get to that in a second. The byte representation of that UN64 is sitting here, 78, 97, 88, a bunch of zeros. And if you take that and you would actually put that in binary, you would get back to that number, except for this little thing called endianness. And you do realize that, so modern computers read numbers backwards. Now, how's that for a concept? Has anyone ever heard of endianness? Okay, so here's the thing. Most Intel CPUs, most modern CPUs, work in what is called little endian byte order. That means that if you were to take the byte order of your memory and display it in what we would conventionally use, your byte order is actually reversed. So a UN32, for example, on a network, if you read that packet straight off the network, and you try to use those underlying bytes as a UN32 on a modern Intel CPU, your number would not be what you expect, because your byte ordering is reversed. And as a result, if you read network data into a modern CPU, you actually have to swap your byte ordering on each thing that you read. It's a little interesting to do that, but I'll show you how that's done and why you would do that as well in the most efficient way in a second. But effectively, that is your byte representation of that number. But now the net result of this is that I've created a slice of bytes that point to where that number is. When I change that number, I'm now going to also be changing my slice. And you see that here. I changed A again. And just like before in the original pointer explanation, something's going to change. When I recreate the slice, and then I take that slice and I convert it back into a UN64 and I read it, I'm going to find, as I do over here, this is where, so I've set C over here, right? I read B, and you can see B is now completely different over here. And suddenly I change it and C changes because it's all pointing at the same memory. That can create some fairly big complexities. But why would you want to do any of this? Can anybody have a guess as to why you would want to do this? Why go to this level? Why go so low level? Why break the typecasting system? Anybody? Okay, man, I need to teach you some creativity here. You've got to start thinking out of the box here. So, how many of you guys work with SQL databases? Right? A lot of people code with SQL databases. And you write these long, complicated insert statements. Right? And it's a pain in the ass. Because you've got to work out exactly what you're going to be, what your fields are, and what your values are. What if I tell you that I give you a function that takes a struct with tags in it, And you take that struct with its values in there, doesn't matter if they're integers, floats, strings, whatever, and I pass it to this function, and this function works out what's in the struct and gives me back my SQL insert here. Would that be useful? Okay, so let's look at that, right? If you think that I'm joking, I will show you in a second that this function here, insert from struct. This is something that we use quite often. And effectively, it takes my database table as a string, because I need to know that when I'm generating my string. It takes an interface, which is a generic type. I can pass any struct I like in there. It takes a tag key. So if you look on a JSON struct tags, you'll have JSON colon whatever. JSON would be that key. And then it's got a sporadic argument called ignore tag keys, which are all the subparts of the JSON that I really don't want to include in my insert statement. And that's just sporadic strings, so that I can ignore parts of the struct as I call it. Then I take this thing and I say table keys, table values, and my ignore map. What am I going to ignore? The first thing that I do is check if that sporadic argument has any length. Have I passed anything into it sporadically? If I have, make me a map of what I need to ignore so that I've got an easy lookup on it. Then I start getting fancy. I take my elements, which is S, up here, that interface, which is my struct, and I reflect it using type of. Now, reflect is another part of Golang that allows you to kind of manipulate underlying data within interfaces. Because here's the thing about interfaces. An interface in Go is effectively just a grouping of whatever. You can put functions in it, you can put structures in it, you can put whatever you like into an interface. In this case, it's an interface that has a struct in it, and interfaces aren't actually structs themselves. They're just complicated structs with methods attached to them. So I reflect to get the type of S and the elements of the underlying structure. Once I've got the elements of the underlying structure, I check how many elements I've got inside my structure. Then I iterate through those elements, grabbing the tag key and its value. And I take the tag key and I throw it into my key table. I take the value of the tag and I throw it into my table values. And at the end of it, once I've done all of that, throwing it in, where I want the tag key. Keep in mind, I've also now got my struct field. And in SQL, if you want to put a string in there, you want a single quote it. If it's a number, you don't want a single quote it. So over here, I switch on the type of the field in the structure. What is this field? If it's a string, shove a string into my table values, that's single quoted. If it's a number, shove it in there, not single quoted. If it's a float, rounded up to 6 digits. If it's a Boolean, because that version of the database doesn't support me giving false or true, it wants 0 or 1. Switch that, put a 0 or a 1 in there, not single quoted, because it's a tiny int. And at the end of all of that, once I've done all of that, I go key string, strings, join table keys with a comma. Value string, join the values together with a comma. Return, insert into table, the table, open bracket, all my key types, values, open brackets, all my value types, and then I've got my SQL string. And from then on, I never have to write anything complicated after that. I just define my structure. Now, tell me how much code that could have saved you. Why are people looking so stunned? Of course, if you take this to a university professor and you hand him something that runs something like this, probably going to have heart failure. But you understand what I'm saying here, because how many hundreds and hundreds of lines of code do you save when you take a structure? So if I look at something like my database definitions, so all of these structs, they're all tagged structs, right? And they all represent different parts of configuration that I use in another system. And some of them are long, right? Really, really long. I don't want to have to go and write ridiculously long print statements to produce an insert query. I want to be able to marshal straight into the struct, which I can do with JSON unmarshal or marshal. If I want to, I can do the same thing with TOML. I can use, whatever. I'll be able to fill in that struct, shove it into this routine, and give me an insert statement. And I never, ever have to keep rewriting the code. This is truly reusable code. And by the way, I still haven't used any objects. And the thing about Golang is you need to start exploring the kind of underlying pieces of it. Because when you start doing things like this, A, your code gets shorter, a lot shorter. B, you start to introduce levels of efficiency in your code. Now, there is this theory in the world today that, well, someone's going to make a faster CPU. Right. And Moore's law CPU, guess what? Moore's law is kind of at the end because they actually can't increase the speed of single CPUs much more. That's why we've got more and more cores. And everybody's pushing out more and more cores. You can't thread and you can't use your Go routines, you're going to run into a problem. Data is getting bigger, it's getting harder to process because of its size. You've got to be able to split it up and you've got to start writing efficiently. And over the last 20 years, people have become very lazy in writing efficient code. I mean, for God's sake, we came out with, every rapid application development language on the planet, and then someone came up with Java, and I don't know if anybody else has ever seen a Java app that runs at a vaguely reasonable speed and doesn't need half a terabit of RAM, but I have. Sorry, I am. You will not find anyone more anti-Java than I am, because it is just slow, it is not efficient. But the world is changing. The world is moving into a world of big data, and data drives everything. And if you can't process that data efficiently and quickly and with efficient code, you're going to end up losing out to the guy who can. And to do that, you need to forget your traditional, what they're teaching you at university about fancy structures and use this function and use that function. You've got to start going to a lower level. And the lower that you go, it's more dangerous. It is, because you are playing with memory rather than things that are easily understood. But here's the thing, right? I'm going to show you the CPU usage on a production server that I have. And then I'm going to tell you just how much data that server is processing every second of the day. And yes, it's got a lot of CPU cores on this server. So, yeah, 88 CPU cores. But you'll notice that most of those are running pretty idle, right? I tell you that that thing is ingesting 1.2 million data points a second. 1.2 million data points a second are flowing into that server. How do I do it that efficiently? You'll also notice about this is that the threads on there, the CPU is not spiking one CPU, it's very distributed. That's thing number one. Secondly, it's all about the fact that I've gone low level. I'll give you another example. It's a hypothetical. You needed to scan a network, hopefully of your own. And you wanted to know what hosts were reliable. You needed to send ping packets to 9,800 devices, which I think is currently what I'm set up to do, right? I think this is the code. So this file, my IP list here of the private IPs, 9,306 private IPs. Those IPs are all sitting on one of the networks we have in South Africa. And didn't like that IP because there's an error in the file on one of the IPs. But as we speak right now, it's not sending one packet to each of those hosts. It's sending 100 packets. 100 sequential ping packets to 9,000 devices. If you were to do that single-threaded, right, it would take you a long time. Many hours. But you'll notice in minutes, I don't know exactly what the time is, but effectively, in a couple of seconds or 30 seconds or so, this thing is going to give me the ping results for all the hosts. Why? Because every single one of them is being pinged simultaneously. I'm literally running 9,000, there we go, 9,000 threads simultaneously. And how much time that saves you? You know? And yeah, when that thing was running, if I would have run an HTOP, you'd notice the thing was taking 15 CPU cores to run, right? Because that's a lot of work that it's doing. But if you've got the machines where your core counts are increasing, I mean, AMD just released a desktop CPU that's got 64 cores on it, for goodness sake. You know, core count, there's lots of it to go around, but you couldn't know how to use it. And the funny thing is that this code is not complicated. You know, if I look at this code, to do that ping, right, the entire code base is 100 lines of code. That's not a lot of code, you know. This stuff, and remember what I said about the queuing channels? Right there. I'm firing in batches, I'm queuing. Here's the other thing. Anyone ever seen a line like that? That case statement taking a time after. Most wonderful way to pause things. Because if you do a time.sleep, well, that's got issues because it's going to block everything. Keep in mind, what does a select with a case statement do? It takes the first one that comes in. So if you want to put a timeout in a select on a socket or something, you add another case statement, and you say time after, time duration 90 seconds, done. If it doesn't get anything on anything else before 90 seconds is up, it'll hit that line and it'll do its thing. So you can introduce timeouts in your code for all of this stuff with a simple one-liner like that. And again, that's using channel syntax. Technically, there is no channel because, well, timeout there isn't a channel, but you can pass it in as if it were. It's kind of cool. You know, so you know, the whole point of this, and I'll give you, you know, all of those little bits of code that I wrote for you to play with. And I'm always available on WhatsApp. You know, obviously I'm a pretty busy guy, so if I take a while to respond to something, please forgive me. I wrote since December 10th. I checked on the production system, 20,000 lines of code. I looked earlier, it's actually 21,100 lines of production code since December 10th. And so I get pretty busy, but go through the stuff and learn it because the possibilities of it are endless. And you start to actually have some fun with your code coming as well. And I'm going to show you what I mean by that. Right. Well, maybe I'm just a masochist, but so we have this. Remember, I said that you kind of end up working with low-level memory to do bits and pieces, right? And I talked about endianness and having to swap byte orders, etc. So, let's skip down here a bit. And I'm going to do some interesting code. This here takes a UN64 and it flips the byte order on it by taking the first byte, shoving it 56 bytes to the 56 bits to the left. The next byte, it shoves 40 bits, blah blah blah, and it shoves the bits. And on the other side, it shifts the remaining bytes in the opposite direction, and then it just does a logical binary OR to combine them all together, and you end up with a 64-bit number that's completely reversed. And it's about the most efficient thing that you'll ever do. If you want to do it to a UN32, it's a much shorter function. But here's the thing, again, on this UN32, in this function here, I'm passing an actual integer in there and I'm getting a result. That means that it's having to make a copy of it, right? Because it's now what I passed in and what's coming out. But half the time, if I've got a packet that's come in, I don't need that copy. I can just manipulate what's come in straight. And if I do it like this over the pointer and I pass it in there, it'll reverse the bytes in memory, straight at the memory outside the function, and it'll be globally accessible. Done. And you can start, it is that type of efficiency. Has anybody here ever worked with a protocol called SNMP, Simple Network Management Protocol? Anyone ever heard of it? Okay, so SNMP basically uses these long strings in this weird tree format to identify where data is. Now, has anybody ever worked with tree structures? Okay, so we've got one person. So what if I tell you that you can do string searching? Oh, by the way, that's another thing. Anybody here ever do string comparisons and find them really slow? So here's the thing, most people who are writing strings and using string comparison routines and using libraries to do it, those things are effectively doing byte for byte comparisons on the strings. That's very, very slow. So let me give you a new method of doing this. What if you take the length of your string and you go, okay, length of my string is, let's hypothetically say it's 20 bytes long. Right? We know that a 64-bit integer is 8 bytes long. So what if I say I'm going to use unsafe to point at the string and say the first 8 bytes is one UN64, the second 8 bytes is another UN64, the remaining 4 bytes, well, that's the size of a UN32, so make that a UN32. So I've got 3 numbers now out of my 20 byte string. I do that to the other string and then I do a comparison on the numbers. I don't have to do 20 comparisons, I'm doing 3. It's a 64-bit machine processing 64-bit numbers. You drop from 3 CPU instructions, or from 20 CPU instructions to like 3 in one go. Simply by changing the way that you're looking at the data underlying. Because keep in mind, as I keep saying to people, a string and a number and a float in the computer's terms are all the same thing. Zeros and ones. So if you can play to the CPU strength, you don't need to worry about string comparisons, do number comparisons. But you start writing some, interesting code. So if I look at a fun routine here. This here is taking, these are taking byte slices and basically converting them straight to numbers. Again, it's effectively all that I am doing is doing a mixture of assertions and casting. And you can see here when you start dealing with network patterns, I start swapping endianness over here and then doing some fancy binary mathematics to kind of play with the numbers underlying because we overwrote the BGP RFC that we use that function in, was slightly on track and decided to do some really strange things. But effectively, once I've done that, I make a copy of it by referencing the underlying memory, and I don't have to keep playing at the upper level. And let me tell you this, all of this stuff looks complicated. Who here thinks this looks complicated? Okay, so as most of you guys, let me tell you something. It's not. And I'll tell you why not, right? If you think about your computer memory, it's like you've got a row of houses in a street and they've got street numbers. Okay, wait, this is Kenya, I shouldn't say that. In a lot of parts of the world, they actually numbers. Right? They don't have street numbers. And you know, when you want a piece of data and you want to go and borrow something from house number 2, you drive down the road, you get to house number 2, you walk in, you get your data, right? Think about your computer memory like that. All that your pointers are doing are pointing where your memory is. Where are you at? And at that point, you can read it out and you can play with it. So, I don't know. Something about borrowing a camera?
Someone borrowed the camera to for it. I don't think that's one.
I don't think so.
No, that's fine, it's okay.
Thank you. Sorry. Cool. Yeah, just continue, no problem.
So effectively, all you're doing is pointing at bits of your memory and then taking what you want. And you can tell the computer and the compiler and the language to view that as anything you like. That allows you to be extremely efficient. If you lose this mindset that the moment that you've got pointers and memory, things are complicated, because really, as humans, we're taught to think, in decimal numbers, 0 to 9. I tell you, if I can think in 0 to 9, it's got to be simpler when I've only got to worry about 0 and 1. It's literally, that's the point. And you end up with if I look at, when you start looking at network programming in particular, has anybody ever read an RFC at all? Okay, so you've read RFCs, you've read some RFCs. An RFC typically will define your network data and it will give you a packet structure. And it will say, these bits in this field represent this represents this represents this, etc. Once you have that information, you're going to know all your offsets in your slice, because you're going to get a byte array when you get back. And you're going to know that if it's a 32-bit section, it's going to be a UN32, almost certainly. So point a byte slice. Tell the compiler this is a UN32, and suddenly you've just unmarshaled your packet. It really is that simple. Here's an example. This here, I have a structure for a BGP open packet on BGP protocol. I know from the RFC, the definition of the protocol, that the first byte of this is 1 byte. So I tell it, it's a UN8, dereference it to make a copy, and shove it into my structure, which is my version element. I know that the next element in an open packet is a 16-bit integer. So point to it at the correct point in the slice, dereference it, and in it goes into the structure. Same with the whole time, it's also a UN16, the identifier is a UN32, and I'm just incrementing here by the number of bytes that I'm moving down to the slice. I also know, because of the endianness issues, that I need to swap stuff. So I swap. Once I grab the stuff, I just swap the bytes in memory around, straight in the memory, because it's a swap UN16 pointer. And I end up with a structure that contains exactly what data I want in a completely readable form, because it's a structure, out of a byte array that's just coming off the network that would look like complete garbage. All I've really done is laid that stencil over a page of garbage so that I can break it down and read it. It's no lot of code, it's not complicated, and it just requires a complete shift in the mindset. The problem is, if you start doing this stuff in a typical university project or a school project, etc., you give the stuff to your teachers, they look at you and then go, this is unstructured, you know, what the hell are you doing? And so no one's taught how to do this. But the net result of that, the net result of the lack of low-level guys who understand coding. So I've been around for a long, long time. I started programming when I was 12. I've been working full-time in the industry since I was 16, actually. And I'm now 41, right? So a long time. I saw the birth of Google, the birth of, you know, Facebook did not exist when I was a kid, neither did Google, neither did Twitter, neither did anything. But back then, if I look at the people who were coding, there was no rapid application development. There was no Python, interestingly enough. It didn't exist. Neither did Go. You wanted to code, you had to know your pointers and your low-level code. And what was born out of it? FreeBSD, Linux, the Unix operating systems, guys like Linus Torvalds, right? And with him came this generation of kernel coders. And back then, your average age of your kernel coder was somewhere between 16 and 18, right? And that was a good, what, that was 92, 94 type thing, right? So if I looked at 26, 27 years ago, and the guys back then were 20, guess what? Your average age of your kernel coder today is probably in his mid-40s, because they're the same guys. There are no new kernel coders coming out there. There's no new network coders coming out there. That is a very scary scenario because I don't plan to work till I'm 100, you know. Someone has to take over. And to do that, you've got to go back to what is a computer? It is memory. How do we address that? How do we point to it? How do we manipulate it? How do we go back to that lower level? And yeah, if you're coding and you're going to your job every day for a check, and that's the only reason that you're ever writing code is for the check at the end of the month, you're never going to do it. Because it's never going to excite you what you can do with it, right? If, however, you're making a living of something that you love, you want to know everything you can about it. And if you are programming without that underlying low-level knowledge, you don't know a fraction of what you can do out of it, because you can do some amazing things. Trust me, back when I was like 13 years old, I wrote about 6 viruses. And those were all in assembler. And you know what? I had fun doing it. I was a hacker too. You know why there's no security in the world today? Because they don't have to deal with hackers that can actually write low-level code. Because everybody's forgotten how to do that. I mean, I see these people who call themselves hackers and they go and download this piece of code that they run against someone's machine, and if it lets them in, they hack something. No, they didn't. They ran a piece of someone else's code, right? The art of doing this, the art of playing at that level, and it is an art form, is so difficult. We held a conference a while back where I brought a particular vendor onto the continent to discuss what was the future of networking on the African continent from an African perspective, so that we could send them home to go and kind of remodel their technologies to suit the African environment. Because in the networking world, I'm sick and tired of being told that I'm in Africa, I must follow the rest of the world. No, we're rolling green fields, they must follow us. Right? Sorry, I don't buy into this whole follow the rest of the world nonsense. And so in this, we were doing a lot of protocol design and looking at the underlying protocols, what worked for us, what didn't, etc. And so I started looking across the length and breadth of the continent for people I could bring into that room to engage with the vendor at that level. Right down at the low level, understand the stuff so that we can tell them what we want to change. After 3 months of searching, I managed to find 7 people. 7 people who really could interact at that level, and believe me, I looked. That is a problem, guys, but it's an opportunity. And so what I'll say to you is, learn the stuff. If you've got questions, ask. I can help you. But I can also say that, you know, at the moment I don't have big budgets because our R&D department is still relatively new. But sooner or later, I'm going to need programmers. And when I interview people, the first question I'm going to ask them is, tell me about a pointer. Because if you can't do pointers, you can't do the work. You know? Tell me about a pointer. Tell me about concurrency. Tell me about unsafe module. And then somebody once said to me, "Would you hire network engineers?" I said, "No, I won't hire a network engineer that can't program these guys. Why? He's going to be 1,000 times less efficient than the guy who can." These guys with their Cisco certifications that can sit and play on CLIs. You know what? I don't care because my code can do it faster. And my job in all of the stuff that I'm writing today, and I think this is why all the engineers hate me, my job is to automate them out of a job. And I make no secret about it either. I tell these guys straight. You learn to program and you learn to get efficient at your work, or I am going to write code that is going to automate you out of a job, and I'm going to do it soon. And I feel no problem with that. So, like I said, opportunity is there. I'm ready to answer questions, and You know, as I find time, I'm always prepared to answer the questions. And here's the other thing, as I said earlier, there is no such thing as a stupid question. I got where I am today. I left school, right? Halfway through standard 8, which is what, grade 10, I was sitting in science class and I went, what the hell am I doing here? This is boring. And I got up and I started packing my bags. And the teacher looked at me and said, where are you going? I said, well, actually, I'm leaving. Cheers. And I walked out. And I walked down the road to my father's office. And I walked into his office and I said, hi, I need to borrow a couple of $100 because I've gotten myself a job and I'm going to Cape Town, which is 1,000 kilometers away. And I'm on the bus tomorrow and I've quit school. And the thing is, my father was smart enough to kind of know me well enough to know that I was going to do what I was going to do, whether he liked it or not. And so he grudgingly agreed. There's an interesting twist to the story, though. My father at the time was head of the South African Teachers Centre and the Gifted Child Coordinator in education for the country. And his son went, well, this is for the birds. And a couple of years later, he wrote an article and he said, I knew this guy, and I've never meant to have read this article. He says, I knew this guy who one day decided to walk out of school, and I thought he was a fool. And I had to revisit my opinions of him because he now earns a hell of a lot more money than I ever have. But the point is, you don't have to be constrained by what they teach you. Use what you learn at a university and at school to supplement the knowledge that you yourself gain through self-study. And don't be bound by these rigid rules that say this has to be structured in this way, this has to be structured. Best practice is whatever the hell works best. Right? Why are you binding yourself to someone else's idea of what is best? What made them so special that they knew best? Because tomorrow someone else is going to come along and invent a new best practice, and why can't that be you? But the thing is, in doing that, when I left school, I had to go and get that knowledge. And remember, in those days, there was no Google. Google did not exist in those days. And so I got it by pounding doors. I would not take no from an answer. If somebody had something that I needed to learn, I bugged them until they gave in and gave it to me. I didn't care if they were a CEO, a CTO, hell, a president. I don't care. People are people. I all started somewhere. But something to teach me, I'm going to go and get it out of you. You know, you've got to be relentless in your pursuit for that knowledge. That's why I say, if you've got questions, never feel that you're going to look dumb asking a question. Because the only thing that will make you dumb and look dumb is not knowing something and sitting not asking the question. Because then you're showing yourself as someone who doesn't really want to learn. So ask, learn, and I'm ready to teach. Whenever I find the time, obviously if I'm busy I'll tell you, but I'll always try and come back to you. And learn that there's so much more to a language than a printf statement and a SQL query out of a library. There is so much more to it. You can do such interesting stuff. So thank you, and I hope that was interesting, and I hope I taught you guys something.
So I think our next speaker is Dan. So Dan, karibu sana.
I'll still be able to just kind of step myself out and quit looking for that one. Otherwise, we'll end up breaking things. Yes, I'm still a nicotine addict, so I'm going to go and get a cigarette. And by the way, you want to know how the Gophers is lost? You used to end up with a cigarette that you lit with a match. Nowadays, you get these things which have touch screens and are programmable and firmware upgradable. You can firmware upgrade your cigarette. The world has changed. So if you ever want to work with the tobacco companies and make lots of money, you still got to learn how to program. Help that out.
So a slight change. So we're going to have Chris go first. He needs to rush this one. So maybe just to explain something. So this group was started by Chris. I think what is
Yeah, I started with the Gophers, but our first meetup only had one person. Strong.
Supposed to come.
Our first meetup only had me and John and some Nigerian and. No, the Nigerian was my friend, so. It's called Ikem. Ikem, I forget the second name, but it's kind of huge on infrastructure stuff. So he gave the talk and me and Job started there. So it was nice. And then I got discouraged. So we didn't have any other meetup for about a year. And then I moved over the management to him and we did well.
So I think our first meetup from one was 178. So the first meetup we did at a year was 178 for sure. So Asante.
Yeah, who knows how to present this? Yeah. So I'm entering into application. My name is Ganga. Not really important, but one thing about me, I realized the more I'm learning as a developer, the more I realize I do not know a lot of things. So I reduced my bio from software engineer and I just tell people I'm a scientist. But what I do, I'm a backend engineer by profession. The talk is going to be monitoring your Go application. I'm going to just mention a few things. I'm going to mention a few pointers. No live coding, no pointers. So. Yeah, I work for a company called HelloFresh. It's based in Berlin. I'm here for a week with this family, so I decided just to do this talk. Right? Yeah, so what is monitoring? It's interesting. It's really hard to define monitoring unless you consider four things, which are here. This is directly from a book I've been reading recently. I'll give you the link. But generally, it's making observations of what's going on in your application. And these observations really need, most of the time, they need to have an impact in the decisions you make in your application. So, like, monitoring will include four things. So one you use it to alert, right? So to know what's wrong in your application, what's wrong, why application failed. The next thing will be like debugging. Like once you get an alert, you're like, okay, my application failed. What happened? If you didn't have any more monitoring in place, you will not know what happened. And then the other thing is you have to also It's also good for like to find out what's trending, because it helps you make business decisions. So like if for instance you're a company that does orders, if you know that you make 50 orders a day, you can make decisions such as I need to increase our orders by 10%, make 60. It will help you make business decisions. And then the last part is planning. If you monitor, you kind of know, you kind of use monitoring as a tool to help you build other parts of your system. So if you include all these four things, you kind of define monitoring as a you kind of just define monitoring. Yeah, so turns out this topic was larger than I thought, because when I suggested it, I thought I was going to talk about the last part, which is metrics, but on more research, turns out monitoring includes way more than just metrics. And it's usually about recording events. So what happened? I received a request. I made a call to the database. I did something in my application happened. And these events usually have context, right? So like I received a request. This request came from an IP in Arab. That's the context. So knowing these little things helps you know more about your application. And now when you start categorizing this context, you get these four areas of these four like main sections of monitoring. The first one is profiling, which we'll explain. We have tracing, which is really interesting for those who do observability. We have logging, we have log, and then we have metrics. So just talk about these 4 points in the next slides, and that will be it. So what is profiling? This profiling is usually you take samples. You run your application for like 2 minutes, right? And then you look at the performance. You look at what happened in your application within 2 minutes. So usually you run your application for 2 minutes, and then you dump a file that has a profile of things that happen in the application, and then use tools to examine this. These things. Most common ones are CPU profiling. So like, why did my CPU go to 100%? Maybe you have a loop that doesn't end. Memory profiling. Maybe assigning variables is too expensive. And then we have network profiling, which personally I've never done in Golang, but you can use tools like TCP down to look at how your computer is doing in a network. Defined here. So Go has 2 inbuilt packages, runtime pprof and net pprof, which they're kind of they've done everything for you. And all you need to do is add them to your application, and then run your application for, say, given most of the time, just 1 minute. If you have like node tests, throw a bunch of work to your application, and then get the output of the profile and look at it. And it's as simple as this. Literally, you just need to include this package with an empty import and run this. I don't think this will run until maybe you block it. I'm not sure if this will run, but this is usually what happens. And the default port is 6060. If you have normally, I feel like most of us usually are web developers because the web is huge. So usually have some sort of router around. If you have a router around, who knows what's wrong with this code? And this is better because I don't want to look for router, so I just say some router. But the problem is I haven't imported the like I just realized on this other side. So on the other code, I should import this without ignoring the imports, and then we do this pprof.index. But then this means I have a route in my application. My application works. I have a bunch of routes, and then I add one random route to that I can use the Go tool to figure out what's happening in my application. Yeah. So going back, if you want to look at these 2 packages, the Go documentation.
Oh, sorry.
Yeah. Sorry. Those two packages will kind of help you profile what's going on in your application. Okay. Yeah, this is this example. So like my function takes 100 milliseconds to run, right? This function takes 10% of that 100 milliseconds is spent on assigning variables. You cannot know these things with this running application. You need to use the go-to to profile them. And I didn't put a screenshot here, but yeah, just these two packages will help you profile your application. So next, go to logging. Beyond log, mostly for debugging. If you come from JavaScript, you've heard of console log debugging. We unlock things is to find out where we are, right? So console log, I am here, 1, here, 2, no. But generally, if you're building any application, you need to have, it's good to have logs that you know what happened in your application. I define logging as recording events, usually with limited contexts, and some additional fields. I think the standard, someone can correct me, I think the general standard is your logs should not have more than 100 fields. So imagine you have a big JSON file with 100 keys, 100 keys. If it gets above 100, it becomes really difficult to look at unless you have tools to analyze it. So that's, I don't know identify, I think that's the thing. We have 4 types of logs. We have transaction logs, so like business events, order was created, user was created. And then we have application logs, which usually you use to know the application is running. So server running at HTTP 800, HTTP 8000. This processes in your system. An example of another application log is database connection made. And then we have request logs, which help you. We have request logs, which usually, whenever you get a HTTP request, just push in a log. Whenever you get a BP call, and then you have debug logs, which are the most common ones. When in your head you've kind of figured out all the parts in your code that are supposed to be followed, and there's like one last catch area, just debug it for more information. So Go has a built-in log package, it's just called log. But most of the time, in production systems that I've worked with, I've never seen anyone use it. People use these two packages generally because they have people use these packages Logras and Zap generally because I think because the people who build them are way more experienced and they have way more features. I cannot go into the debate because it's usually a debate of which one to use, but like what works best for you, it's fine. And sorry. Oh, it's true that that's what was confusing me. My numbering is wrong, but very right. Then we have tracing. Tracing is following your code paths, right? I define it here as events, functions, and the structures at the point of interest. So like I made a call to the database to insert records, right? You want to find out what actually happened during this call, right? So you oh sorry. Okay. Yes, so I have an example here. I want to trace the user created request, which is usually normal. Usually my code will go to my router and then probably do some intended validations. Then go to a repository where I am going to store my data and then I get back a response, right? I can track the time it took for any of these steps. That aspect of finding out how much time was taken in these steps is what can be referred to as tracing. This is the application. Then we have this thing called distributed tracing. Usually, nowadays people build everything in microservices, or they connect. People build small systems that talk to each other. So we have distributed tracing, which is usually things like your application structs to another, your microservice structs to another microservice, which structs to another microservice, structs to another microservice. So you want to trace, you want to find out what happened within these three processes. Yeah, I say yeah. So if you have services, of course, they're talking via any of these protocols, HTTP, any RPC or TCP, and they attach one ID, and it traces that ID across all these systems so that you find out what happened where. And I have this example, which is directly taken from so the company that started this open tracing thing was Uber, and they have this example in the Jaeger site, which is so this is what happened. So like, this is one trace. This is one trace, and it kind of tells you like the front end came up to here, and then you talk to something else, which to this minute talk something else, this minute, and you kind of see it, and now you kind of start thinking where your application was the most time taken, right? So like right now you can see most time was taken here, and now I have context and I can go and find out. I can go digging and find out and try looking at debugging that particular part. If you do not have tracing, it will be kind of hard to find out. Yeah. This UI is for the Jaeger. It's called Jaeger. That's the name of the application. That it exposes like a data format which will be read by this UI. Yeah, and Go has specific tools to use this. When Andrew was talking, he was showing us, I think part of his CPUs were idle at some point. So like using the package that we're entering the trace, you can find out which parts of your CPU are not being used. For example, at first I said if you run like 1,000 products, they will not use all your CPUs. They probably run in like maybe 2 threads. But then this package, if you go and run about this package, it will help you. It will give you a UI telling you your code ran well, but your code just used one. You have like your code just used one core, right? So you kind of have to figure out how to refactor your code to use all your system, everything in your system. Best way to find out about HTTP trace is by watching. There's a guy called Bill Kennedy. He has like an advanced Gophers, and he talks about this thing in detail. So get it whenever you get it and look at it. And this is an example, for instance. It's an example of the UI whenever you use the runtime.trace. Usually it's tells you a bunch of things like routines running, tells you garbage collection. You figure out like there's nothing the CPU was doing here. It's in your mind, and now you start trying to find out how can I use the code to use all my resources. Okay. The last part, which is what I do a lot, and which is what I thought I would talk about, is metrics. Metrics are interesting. You just track aggregation of different type of events over time. So, like for instance, how many requests did I receive today? What is the request latency? How long does a request take to complete? What is my CPU usage? These are metrics you can collect in your application, and the way libraries are written these days, they do not add any performance impacts on your process. But it's good to collect. If it's good to collect them for data and like for business decisions. How many decisions are active? We see all these things in a lot of places. They fall into mostly categories. If you have any metrics, they definitely fall into these things, and they are counters. So like how many orders they create, right? Counters are usually these atomic operations. I don't know whether I've never been to the counter, but I think most of them usually add, not subtract, but I think you can do a subtraction. We have gauges, which help you set things. So like these are the operations. So like counters making add budgets set, measures record events. So like let me record my CPU usage in the next 1 hour and see because I'm running a certain process. Yeah, and then you end up having if you glance at this, you're gonna having a pointers and histograms. Usually, I think I have an image. Yes, you end up having things like this. So like for instance, if you're running most like if you're running for instance Kubernetes, like this is an instance, it says 2 pods are running. If maybe they get too much load, it will spin up another pod. I don't need to go and find out if I have a dashboard like this. This is just increase. Memory, it's just using the fact that the end user memory is fine. You cannot get this unless you collect these tiny metrics. Usually you collect the metrics in your code and then you export them to a format. The most common one is Prometheus, and then Grafana can collect those metrics and do a nice graph like this. Yeah, I mentioned this, but this is the history of how metrics went. 3 years ago, we were mostly using Prometheus and a library called StatsD to collect metrics. And then session came along that people had a lot of distributed systems. And then people had it was supposed to be standardized because in software there's a lot of opinions. So we had an interesting come up. Then we had OpenCensus, which wanted also to standardize collecting metrics and traces. Then recently, the guys sat down and were like, dude, let's just do one thing, and they formed this open telemetry. So if you are going to do metrics, probably now moving on, you're most likely going to use this. If you focus on the open source side, probably going to use open telemetry. And the idea there is let us standardize how we do metrics and how we do tracing, so that not everyone comes up with their own idea. Yeah. So I pushed it here. So open tracing is still the specification has been defined. You can read about it. It's in active development, and I have this. Okay. So I myself, I write a lot of these things, but I'm still using the client library. So like I'm using the Prometheus library to do it. Unfortunately, you have the same in browser. But yeah, this is so the spec has been defined on what's supposed to be done. And this is the Go library. This is the Go Meetup which we're talking about. And down here, we see in Alpha, they kind of tell you the status that they're in. So like in December, they did the Prometheus export. I already had the standard out exports. It was completed in December, and keep following it. But like most systems, or rather most applications I've seen, are using the Prometheus exporter and Jaeger was the first one to be done. So these two. So that is pretty standard. And if you want to look at it, if you come to this repo, they even have examples of all the things. So we have Prometheus, which is the metrics. We have Jaeger, which is the tracing, and you don't have to know the details. You can just come look at the. Let me pick Prometheus for instance. You can just come look at these things, look at how they're implemented, and then just add it to your system. There's a I added this here. So there's no. I add this thing here called Ops Live with Josh McLeod. This is one of the engineers working on OpenTelemetry, and he has this talk. He has this. It was I think it was a live session that he talks about these three things and the design thinking on how on how they came up with this and they settled on these trivial metrics. Just look at that on YouTube. You kind of, it's like a 40 minute video. You kind of figure out how these things were designed and how they work in Golang. Yeah, so towards the conclusion, so should I add one change in my application? Yes, definitely. We do it by default. Sorry, Andrew, but we do printf all the time. When we're setting the application. But generally, if you reach a certain, sometimes you cannot start your application and just start and add all this tooling at the beginning. It doesn't make sense. And I referred to this talk by Robert Travis. It was last year in I don't know the conference, but what he says is whenever you start looking for a solution, so like what you do is just create one file, right? Main.go, make a request, log it. Go write your code slowly until you find out, oh, my code is slow. Then maybe now start adding metrics at some point, right? You cannot start by instrumenting all your metrics, all your logging, building one of these libraries at the beginning. It doesn't make sense. Just start writing a solution, and at some point when you now need to track things in your application is when you start adding them. Unfortunately for businesses, you need to do this for businesses need data to make decisions. But when you're starting, probably not. Yes, like I said at the bottom, incrementally. Yeah, so that's it. Any questions? Yes, and
I have a question. You say you're not trying to add this stuff incrementally. So maybe it's because of the nature of what we're doing and the fact that we demand optimized code. But I have a simple rule that if you're going to commit into our internal repos, you better include the profile fast code, CPU, and the memory that they need commit. Otherwise, I'm going to erase it up hundreds. Because my question is, with the CPU profile, you're effectively 2 or 3 lines of extra code to put it into a function. Why not profile every function and optimize it so that you're not waiting for things to get slow. You're making sure it doesn't happen and then having to go back and revisit. Because if you end up writing a 5,000 line long application and you've got to start profiling after that, particularly if you've got overreach running all over the place, etc. Surely it's easier to get to know upfront functions like function. That's what the problem is. I mean, what are your thoughts on?
I would start by saying this will be a really good code review, but it depends. It depends on the business. Sometimes you need to do things really quickly, and writing profiling, writing all this, adding all this profiling and metrics may take time if it doesn't exist in a system. If you get into a company that has these things defined, like well and good, and it's part of their systems, well and good, but which means probably if you make a BI to that repo and you didn't do it, they will tell you. But it depends on the business, right? I was saying here, do it incrementally mostly for our personal projects. So start your project. You don't need to put any metrics at the beginning. This usually try to figure out like how do I read this CSV file? That's your biggest problem, right? Not how quickly do I read this CSV file. Just find out how to read it. Then when you find out you're taking 1 second to read it, now start digging deep and start digging deep and look at it like why is it this way, right? And now you start adding this kind of things. Those are the good. But if you're in a company that has all these things defined, that you have to do it.
You don't find that it becomes almost a force of habit once you start doing it.
I can't hear you.
Yeah, I say you don't find that it becomes almost a force of habit once you start doing it. I mean, if I look at it now, even when I'm writing personal things, I know that the first line of my code is going to be the profile, and then the last line is going to be turned off. And it becomes a habit. And the thing is, you may never go through those profile files that it's writing out, but they're there if you can read them, and you truly just fall through to go there. And so what I'd say is, if you can make it kind of part of your mindset that this is what you do, it will help you immensely. So that open telemetry, by the way, is very interesting.
Yes,
It's built on prototype, and that's the other thing I can say to people. If you really want to learn about domains, it's a Google prototype. Most amazing data exchange method.
if you're on Twitch, they have like a weekly thing we do on Tuesdays. Can send you. Yes.
I have a question. I think two questions. One is observability is kind of open to let's go on any other kind of language.
So it's a spec. It's for all languages. So they define what tracing should look like and what metrics should look like, and then it was like I don't know if FC, and they had months and months of discussions, and then now they started implementing. So there's a library for whatever language they're using.
It's actually more than just language. Telemetry as a whole is now being used network data, it's being used for language data, and because most of our scopes it's tied into gRPC, which means that they're using it for a lot of things.
The second question is something about experience. I'm willing to add a bunch of code, but at some point, I don't know if you code. I can run my event server and decide the master system. They are all running the server for you to do this. But at some point, the HTTP server will be seeing the bugs. So I'm doing the way of tracing so that I can see where this exactly lost. But it's running at a certain point, there are a certain number of attempts running. If we start blocking up, I have to keep using the Linux command. So it's kind of hectic, and I wanted to know what's your problem if you really talk into the first thing that you suspect.
I would suspect that I have a blocking channel because I've experienced that quite often. A good example is like having a unit run and then you have a debug fund you forgot about. That will be my first suspect, but generally if I have I would put it at the first part of tracing. If I have a bunch of traces in my context in every function I call, I would kind of figure out what's wrong there. But if at some point your application stops working because of something algorithm, there's probably something important. Yes, not sure how to debug that. Someone has more experience with it.
I can tell you how you debug that. The simplest way to debug that is if you create a unique variable with global variable or you pass in the context, make it integer. As you put something into a channel, if you're expecting a reply top, you implement that. And you put it as you put something out of the channel, you decrement it and you print it. And if that thing is sitting exceeding the length of your channel depth at any point, you know that you're going to get a block because your channel is going to block you within the channel file. So you can use a global where you're just implementing and decrementing, where you push it onto the channel and then you off the channel. And then you track what's in there and you'll find it. Because I do it, you probably see the channel issue. And that's what's a good way to do that.
So I haven't done sort of fixing what we do at times the past years or the past just and already long.
In an issue like that, I don't think the loggers are confined to all institutional tracing is necessarily required either, because you actually want to figure out where someone you really want in that situation is dump to a long file where you're implementing and implementing that local, so you can say function X showers onto the channel, but before the channel here, this is how my channel buffer is, and you use that, to go and let it go on. And the other thing about logging is that I'm quite happy to share how the logging function, I've got another logging function which gives you context, but it's not loggers or something that's, 10 lines code, it's not 30 lines of code, it's simple control. And I'm happy to share that with people.
Yeah.
So, you know that roles are people I actually agree with that. Yeah, that makes sense. I have a question for you. In your logging metrics, have you ever done any of this stuff in the context of low compile with a sample?
No. No, I haven't touched WebAssembly.
Yes and no. The issue that I've had with WebAssembly that I've really actually quite struggled with is that one special WebAssembly application is not a thread. So you're firing so many threads just to stop it blocking, because if you block the main thread or the WebAssembly application versus your browser, you're going to crash that application in a second. And so I just wonder if anybody's done any kind of profiling and working with WebAssembly because that is in here.
Any more questions?
Usually, a whole people will invest in working. So, depending on what they're going through in the past, the reason why they should be so it's more dependent on the business and the first way is you want to make our own every single day. I would say if you do something yourself, you actually increase the legends of the game. Was not there, the pilot so and such will be very free that what we want. And most of the day is on the start focusing on the active things and the I would say also self-dressing circumstances. Very proud of you.
Yeah, but the good thing is we have these things being built by really smart people. So the hardest part is usually like instrumenting it, just how it, but then once you have it in place, it kind of becomes easy. It's just usually, if you have another function, if you run it somewhere else, it's most of the time is usually just either copying the function, but instrumenting is really the hard part. But like you said, yeah, like I was saying, incrementally, fix the problem first and then add some metrics.
I think I have a problem as far as tracing is concerned. The whole question is that. So, at least in my experience, if you make it a habit to start doing things like TDD and you start doing things like tracing, when your project is starting out, it becomes a habit. And eventually, even if you're stuck in terms of time, you have very short time. Eventually, you'll thank yourself in the future. So I would recommend that instead of putting things like logging and tracing and something to do, yani isiwe ni kitu at the end of at the end of the project that you have as your plan, that's when you want to start thinking about CDD and logging. Because it's going to become so hard. Like imagine you have so many lines of code and now you have to go through every function and put tracing there in terms of when you're going to your metrics. So if you make it a habit and you start out your project with that, it's going to get to a point where you can't even do a project without making that part of your habits. It makes your coding experience better, it makes you very aware of what's going on in the system. So it's not a habit for most of us right now, but adopt it. You can't just avoid it.
But this is another thing. If you can say, what code to do this is what you write use. The one that has both volumes of one code, import the library and put one of the right code. It is worth taking the time to write and completely generic library that you can import and every piece of code you write that's a complicated.
Every function you write, you do something.
And it becomes a mindset and there's no extra work for it. Literally one code.
But the moment you think of it as a daunting task, you will never get it done. You never know how exciting that is.
Yes, so those improve because we have context these days. So if most of the functions have a context, it's really easy to add these things. But get your point. Okay. So final thoughts. This is a question. I know it's fine. I've been told that I've done this.
If you're talking with millions, you are must be another I want to tell
Yeah, so that's all.
So next is Duncan, software engineer from Mandela.
The age of us. Right, so I'm Duncan, and that's it. I'm done. And I'm done. Right, so I'm going to be talking about that thing, although it has nothing to do with whatever it is there. I just thought, an interesting title. So let's talk about APIs, and specifically product APIs. If you are working on a product that is in a microservice that you're trying to do infrastructure and you're consuming your APIs internally, that's not what I'm talking about. I'm talking about product APIs that you expose to build the product or that are consumed by clients. And today, commonly, it's become a habit for us to, I call it the dream of less. We were sold and told that this is the way to build APIs, that you have resources that are tied to, I don't even know what, and then these things add up to be mostly HTTP based, right? So you end up thinking in terms of resources, and in most cases, you don't follow this because your product manager comes and says, we have this new thing for iWatch because it's 2019. And then you're just like, let me just add an endpoint called iWatch, like APIs of iWatch, right? And the very idea that these things are exposed to different teams, it becomes hard to document and keep what you do. So tools like Swagger came along and now you're like, hey, we can write these awesome typed endpoints and we can generate some sort of GUI to explore our APIs and it was amazing. Until it wasn't, but it's still amazing. Like, I don't know, who am I? I don't have opinions about this stuff. Also, if you're using internal architectures, I think honestly, gRPC is amazing if you are communicating across the infrastructure. But if you're building, I guess there is gRPC for web nowadays, but yeah. So Facebook came along and sold that another dream. Yay, we can now build some. We have this SDL thing that we can define across areas and then we can expose it. And to be honest, I found it amazing. Probably why I'm talking about it. So yeah, so GraphQL. So just to know my audience, how many of you are familiar with GraphQL? Yeah. So GraphQL is a schema-based spec that allows you to define your API schemas, and then I should just visit the website. Like, honestly, what am I doing? For those who are not familiar, Asia, right? Query language for it's right there. Query language for your endpoint APIs. So if you ever work with GraphQL, there is always one thing that bugs me. But whenever I'm doing this, I'm left with two things like in Go that don't allow or in any other programming language. According to this is a way of designing that should be schema-based. Right? So if I try and build my APIs from a schema perspective and say, I'm going to be schema first. I'm building this API and this API, I'm going to define a schema and then build that. I find myself, oh, I did this in Ruby. And I found myself just in this hell of undefined text. For instance, your GraphQL query, I'm not going to talk about GraphQL in general. So if you are not familiar with GraphQL, I suggest you. So if your schema in a GraphQL becomes say something like, oh, this is maybe I can show you here. So maybe it says, here is a query for users, and in your schema, by the way, the stuff that I'm talking about, the SDL, is this language, the schema definition language that they use. In that, it might say, oh, this query returns a list of users or a list of donkeys because we are creating a donkey API. And within that, I end up finding myself within my code returning nulls, and there is no way to catch that. Because I can write test, but I would like to have the API itself catch that for me, because the moment I write the schema, I want the schema and my code to be in sync without having to modify or change one and then having to change the other, right? So of course, when I'm writing GraphQL servers, I always write them to be schema-based. I want my schema to reflect my code base. And I know some people are going to be like, yeah, that's not how I do stuff because opinions, and that's amazing. That's why we have our, yeah, so, and I was kind of wondering, is there a way in Golang today to be able to do that? To be able to take my schema and generate a GraphQL server without map interface. Because at the end of the day, you either have to do that or you either have to copy every single line of the schema and be like, this is a user, and then give that, and then we pass that, and then all that kind of stuff. Which is okay, but I have Golang. I find just calculating Python, right? Works. So yeah, and there is. And I found this tool and I love it, honestly. It's GraphQL Gym. So how many of you have ever worked with Golang code generation? Yeah, so I can leverage the tools of Golang that Golang provides for me to be able to take my schema, generate my GraphQL server specifically based on the schema ATL, right? Yeah, so I suggest you look at the tool. It's just was adapted by 99 designs on my I don't know what they do. I have no the other tool that I use. And here's the tool. Right? So it allows me to take a schema first approach. I have a schema, generate my code, and then expect for us at any particular point, I don't have to do stuff like this. My schema and my code base are going to be a reflection of one another. Right? Yeah, and what simply happens here, you define your schema. So aim for a little demo that is probably completely what I expect. You define your schema, right? Because this is my awesome API for cities. It helps you query the name of the city and the number of human beings living in that city at an undefined time. Because I didn't read about that. And then once I do this, I use the Golang generate tool. And what this does, it takes this schema and just generate a model file for me. Right? I can either take this and map. So they do provide a way to create a mapping between. So for instance, if you already have your, I don't know, proper buffers things that you are using on the infrastructure, you can still use those models and say, oh, you can use the YAML configuration here and say, oh, I already have these types. I just want you to point to this and use your magic and marshal them for me because I don't want to do that. Yeah, so for this case, this is a simple case. I just want to generate mine because this is a demo. And yeah, so this generates a file that knows how to. So for instance, if you think about the process of writing a GraphQL server, right, you have to be able to do parsing for your GraphQL queries, and then resolve, right? So I don't want to think about that stuff, and this generates them for me within the specific typing within the GraphQL type. Right? There are other tools in using Golang, but most you end up like redefining the whole schema using Go structs, and this is a thing, it looks like this, and then it has an object, it's query, and then inside that is, and I find that unsexy. And then all I have to do here is be like, this thing provides me with an ability to just say, I'm going to have this thing, put it in a handler, and then all I have to do is this part, right? So within this, well, we are defined GraphQL interfaces. All I have to do here is now simplify my interfaces with my queries and maybe indications here, right? And for this case, if we wanted to create our setting, we would just, I don't know, just create the code to create the setting there using your awesome Golang programming skills. And probably some memory stuff and monitoring stuff and all those cool things, right? And we mark our database, right? So, but like the beauty of this is within my GraphQL types, I'm able to get the schema types, right? Well defined as Golang types, right? So, for instance, if I take if we look at our input in here, in our GraphQL schema, that is well mapped to this thing, right? But this one is a good, and I'm sure someone here is thinking, code generation, stupid idea. Well, that's why we have a wallet. Yeah, I think I'm done. Questions?
Here's one question, because I'm not code generation.
Huh?
But if you ever thought about modifying code generators, you generate it into modules. And the reason that I ask this, is one of the things that we do very interesting parts, is when you want to redefine a schema, and a long-running application without ever reloading the application, and you need to rewrite the schema live on the fly without recompiling it using generated code, that should be a problem. So something that you might want to explore, you might find to really interesting, is if you make the code generate in terms of a Golang module, and your function is a pointer to that module, you can redefine your schema by simply uploading the module and reloading the module while the application is still running, and simply point the function pointer at the newly loaded code, and effectively you can reload virtually any aspect. In fact, all our systems are built like that, because if I want to do an upgrade on a production system, I don't want to have to restart the application, so I just unload the function and reload it from the module.
Yeah.
So it's something you think about.
Yeah. It's perfect sense. And for this case, like the code generation here is purely generating from the schema type. So it doesn't limit you from whatever you want to do, whether you want to put it in a model. Because in fact, if you look at here, within our YAML file, I can decide that whatever generated code I want is, I don't know, it can even be an installable package that I say, oh, this is just type stuff that you can go get. You can still do it. Yeah. Ideas, insults, comments, questions.
How good is the derivative approach?
Well, question of how good is it?
It's very subjective.
Generate some, look at it. If it doesn't make you feel, if you feel it's not okay, it's not. You're not being.
I needed to go back and rewrite a lot of it.
No, that's the thing. I have written like 2 production stuff with this, and I don't feel I've ever touched the generated, because what the generated code does, it's only 2 things, right? Provide the passing back and forth between the graph, right? And whatever stuff you're doing is simply on, you have control on how to mediate this, right? So it's simply a mapping between, and unless you want to redefine GraphQL, right? And unless you want to say, I'm going to say that queries don't look like this, unless you want to redefine that stuff, I don't see any reason, because 90% of the code in the generated file is purely to pass from GraphQL types that are on GraphQL to Golang types. So I think it's pretty okay. And to be honest, and like, if I'm writing this stuff, I would prefer, this is subjective, right? I would prefer doing this instead of spending countless hours trying to redefine types between a graph API and my production stuff.
I mean, I'm asking because I've seen this in a slightly different context. And what's the question? Do you fix and you can write the code? Because at the end of the line, a lot of times it's more efficient. When you let the machine generate it, what's the optimal way to do
Yeah, this generates the pass up value. But even creating something like GraphQL code, you write
GraphQL?
GraphQL code. I'm not sure it's on you name the schema definition. At the end of the day, you're going to require because it so pass it to my code. So at the end of the day, this we are relying on someone else's code, regardless of whichever it is. So you better have generated fast and generated afterwards during the period. So, but the process embedded is the same process of doing as someone else in the program.
Yeah. So, and the definition for this, see, for the inline stuff, right? I'll head up to, like, when you do the GraphQL code, right? It just allows you to have an interface between, oh, here is how my GraphQL server stuff works, right? But what it doesn't allow you to do, that's why my job was called type safe stuff. What it doesn't allow you to do, it doesn't reflect your schema, right? So yeah, in your GraphQL server, you most probably at some particular point, this is me, I'm going to write and I'm going to say, I don't know what type is expected by like some input from that schema. I'm just going to say, let it be an interface of like V interface brackets, right? Which yes means something. And that's the point. Yeah, I do get that, but at this particular point, the GraphQL, Go GraphQL stuff, yeah, it allows you to do that. But
My point was exactly when you were asking about the connect.
oh,
If you are saying coding as just in the past, you use the GraphQL to manage basically else by someone else also.
any other comment? Huh?
Yes, and modify. So if I look at how we write our code, right, we follow what is jokingly called the Bezos mandate. The Bezos mandate in 2003, 2004, Jeff Bezos declared in Amazon that if data was to be exchanged, it was via an API, and anyone who exchange it via another method, be it shared memory or USB sticks, would be fired. And he then enforces it. And there's actually a very interesting article you can read online, if you Google it's out there, with an employee of Google saying the reason that Google has never managed to do certain things is because they've been pulled like that. So if I look at the way that we write our code, our APIs are almost defined as we write the code, because as a rule, every struct that we make, for any reason, anywhere in the code, is tagged. We tag every single element of the struct. Now I'm trying to figure out, in terms of code generation, etc., when you're coding like that, when you are defining your APIs literally as you're writing your app, because they are part and parcel of everything. How do you kind of put this together with that?
I mean, there is.
I'm not saying our way is always the best
Yeah,
way to do it.
yeah.
You know, it takes, it's a mindset, and it takes time, and it takes work to get that.
Yes, I'm getting that part. And for that perspective, my opinion would be, well, if you can do that and you can be able to generate APIs on, right, as the product grows or whatever, for me, I would still be able to get this way of working, right? And I know it will be able to do this out of like, you can modularize this and put it in a whatever, but I still feel, right, because GraphQL is not about, it's not about logic, it's not about the logic. You shouldn't have the logic in your GraphQL code, right? It's just about the data exchange using GraphQL. So I do feel like, yeah, even if the schema changes, right, then, and maybe the workflow might be hard when you are doing something like this, if you are, that's your approach, but I still feel you can do it, because if at a particular point of your product the schema changes, right, all you have to do for this case is update the schema and then regenerate that, but your logic doesn't have to be like mixing your business logic with the GraphQL transport layer. I think that would be a bad design in that. Any other question?
I've seen this every this week, but I think it's a good idea. She was a one of the server, and they talk about comparing this in a similar manner, where the start is just in that exchange, just like so everyone has a problem with this approach. She doesn't have a problem with the PLC, but the fact that most of you that use the PLC for themselves shouldn't have a problem with the same thing. It's not something you have to feel nervous. It should be something you do at the same time. And for those people who are, I used to be that kind of person who like to remember you. But it is a point where you can't really know that in the first place, the way you are used to it. So I think it's a good approach, and I feel like it's something very.
Yeah, so as I said, I'm Duncan, and that was my quality draft talk.
So So the last talk is by Novak. 20 minutes or less. Yeah.
Hi. So, okay, so I'm Kelvin. For Nova, whichever you get. Yeah. So I'm a student. I'm also software developer. So yeah. So I'm a backend engineer. My starts being especially Python. I'm also trying to see if there is something that I can support with the current engineering staff. Yeah. So today I'll be giving a talk about building a REST API with Go. So apart from that, I've actually managed to wind up on the code like 2 minutes ago. So I've also done its front end, so you'll be able to see what I was doing. Yeah. So I have to also I'm also a Microsoft Student partner, so it's all sponsored us for lunch.
Yeah.
Yeah, so I will go straight to why you should use Golang for web or for anything else. So Go has concurrency and faster performance. I think that has been covered. So it has like concurrency and Go routines built in as primitive parts of Go. I hope you get what I mean for that. Right? Yeah. So another thing is it's native support for frameworks and libraries. Yeah. So anything that you need is a high probability that you will using the Golang language. Uh, then high speed. Uh, so it's basically fast compiling and you can edit directly in the web. Yes. Okay. So sorry for that. Yes. Okay, so I will push the code for the same. So maybe, but to take you through. So in Chris' talk, he was talking about like he was really talking about most of the things that I'm going to use here. So I'm going to use so Go has like an inbuilt. You can think of it as like an HTTP client, something of the sort. So then another thing is we're going to use Max. So if you go to Max, for those ones who have done React, you can think of it as router. So Max. So it is a powerful HTTP router. So it's built for Go. And the way you just install it is you forget Max, whatever. Then this is basically how you initialize maps. Then you define your routes and you good to go.
So a bit of what maybe so this is basically the code that I was doing for the same. You have I was doing a REST API for creating a house and maybe some owner. You have a struct defining the things in the house. Then we have an owner here. Then we have our slice of houses there. So then another thing is now the using basically the REST approach. We just have to go down. So in main, as you can see, I've limited the router. So I used to go get and I installed this one. Then I'm calling max.new router, so I'm initializing a new router. Then I'm registering the function. So this is how you register an endpoint. Then I'm saying that for the first one, let it be an endpoint of get houses. Then the method, so it's a get. Then that one is also a get, but it's for one. Then the other one is for houses. So it's you can create house, so that is post. So basically, then down here, I use it now pause, so I'm trying to give access to my front end to here. Pause origin URL is not on the front end. That was an error for me. I was back for 2 hours, 2 days. I was back to the pause origin. So basically, then I'm having I'm appending to my slice. So I'm appending out 2 houses here. So I have if you look at the struct for houses, we have an owner, which is basically this guy here with the first name and the last name. Then it's very simple code. Then we get houses. So when you are creating when you're creating these functions, if you have done express, you can think of it as the express way. So the first thing is basically from our HTTP module, which is here. So we pass in the response writer. So then we pass in the HTTP request as our second argument. Then we set the content type, that is the headers. Then if let's say you're trying to get something from somewhere, like you're trying to struct the ID of that endpoint, you just call max, then you pass in the variable that you're trying to access. So, So then I'm basically just explaining the code, but it's just self-explanatory. So the reason that I decided to do this talk is I wanted to convince people where I work that we can use Go to do stuff that we do. So it is basically very simple. Then as you can see, we have JSON here. So in JSON, we are using JSON to encode something that we're sending out. So maybe something that you want somebody to see. Then invisible. Is it invisible? No. It is not. Huh? Sure. Nazari? You go back. So basically, so I'm using the inbuilt HTTP module. So you can think of it as going. Most of the cases, there is high probability that working in another language you might need to do this out of the roof, like it's not offered within inside that. So that is one advantage of Go. Then so basically, so you can do REST with Go. Because it takes 20 minutes. So you can. I will push this code, but it's something that is self-explanatory. But one thing that we love to note maybe is the fact that number one is that write less code. Then another thing is that this, as in you can deploy this to any environment. So I was trying to do an Azure demo, but it failed. That was actually amongst the focus because Microsoft was like, you must do Azure, so yeah. But it failed, so I don't do that. Yeah, then basically I'm allowing my front end here. So after calling all these methods, so get houses, create houses, and all that, so I'm allowing because like to say this guy is good, then yeah, so if I come here, then the way that I run that is go view. Yeah, so that is deployed, it's running. So now if I go to uh, yeah, so it is basically houses with two houses. Yeah, so I'm doing like a fetch, so this works. So you can do rest with go with less code, it's much fast. Then another thing is it's just awesome, it's interesting. If you can do less with that, so this talk was supposed to come fast, so too bad for you. Yeah. So another thing is I'm of course logging like instead in case of any stuff. So basically adding and removing houses. That is 13 minutes. I don't know what to say fast. Any questions?
How does was it work with Slack? Is there Slack sort of documentation?
I've not tried, but I suppose.
And as the easy ability sort of do documentation, because you know which documentation you require, and it just works like the same one for the load. It's the same, but now you have to prepare something, so it's still the same thing. Now, not only if you're working with your place, or you have business work, or you have a family business work, it's the same.
So actually, one key takeaway that I took from a second talk was by Microsoft was that like people tend to believe that when you need to build something robust, you need a complicated language. So, but I've been working for Go like for 3 months now, and I think that like that is a lie. So, like we don't really need such big spectacle language like C++ to achieve uh, like let's say complex stuff like we need to do that. Yeah. So yeah, I think I'm done. So I will push this code to the repo. So in case you just want to go through it and see how maybe you can come up with something or learn from the same, you can do so. Then also I will be looking forward to start working with somebody on something on Go. So if you are interested, you talk with Juma, there's something that you plan with the same. So otherwise, since there are no other questions, you know, yeah. Ready? Oh, now you should be. I don't remember my password. So thanks guys, and have a nice time. Also on lunch, who are vegetarians? I'm vegetarian. So there is veggie delight, so that is the subs. There is veggie delight, there is sliced chicken, then there is chicken teriyaki. There are also some toppings, so if you need ketchup, mayonnaise, or mustard, yeah, they are there. So yeah, so just for those who, yeah. This page.
So if you look at a really large company like that, right? In my department, it's exclusive to go there. In the IT department, they like to play with Java because they like to be slow and done. So it's actually a more department question. comes down to, like everything else in life, you use what's fit for purpose. And coding is really good at most things, but a lot of things which I would not use coding for, you know. It just depends on the purpose. But as a primary, you know, I know for other departments, other than where I start talking to CTO and December to still get these a little bit more performance out of things, but then just
really very, very